As an automation professional, you may require monitoring, controlling, or testing using real-time manufacturing or process plant data from an Excel spreadsheet. This data could be helpful also to your management, research, and other department personnel requiring real-time data for decision-making. With this and the previous lesson, I'll show you how to achieve this and more using Microsoft Excel and communication called Dynamic Data Exchange, or DDE. In this video, we will use Microsoft Excel to write data to Rockwell Automation Studio 5000 using RSLinx Classic and Studio 5000 Logix Emulate software. The overall block diagram of how the programs are interconnected is displayed here. The Studio 5000 Logix Emulate will communicate with RSLinx Classic, and in turn, RSLinx will communicate with Studio 5000 Logix Designer and Microsoft Excel. At RealPars, we love helping you learn. So if you enjoyed this video as much as we enjoyed making it, click the like button. Subscribe and click the bell, and you'll receive notifications of new RealPars videos, so you'll never miss another one. Let's recap on what is DDE. DDE is a Windows mechanism that enables applications to communicate with each other. A DDE communication is known as a conversation between client, which initiates the conversation, and server, which responds to the request. To initiate a DDE conversation, a client specifies the three items: the application, the name of the application it wants to talk to. Usually, this is the application executable's file name. For example, RSLinx. The topic, the subject of the conversation created by the user, and should be something which makes sense. For example, RealPars Excel. And the item. Any number of different items may be referred to identify data to be passed between the applications. For example, Excel recognizes cell references as items, and RSLinx recognizes program tag names as items. So, let us begin with the previous sample PLC program. I've created a Studio 5000 Logix Designer program called RealPars XL. You can find the download link to this PLC program in the description. In the previous video, I opened the Controller Tags folder to create two tag arrays called Dint Array and Real Array. So, I can see the values in Excel when I select the Read and Write operation within Excel. I'll set values in the Real and Dint arrays. Next to the Dint Array and Real Array tags, I'll select the plus sign next to the tags. Once the plus sign is selected, the tag array will expand to display all of the elements in the array. The Dint Array and Real Array, each of them with 10 elements, and the values I will enter to, allow me to see the different values in Excel. Dints are integer-type values, and reals are floating-point-type values. I will save the Studio 5000 program. This is a good time to start up the Studio 5000 Logix Emulate software. The Emulate software will emulate a virtual Rockwell software PLC on a personal computer. Locate the Studio 5000 Logix Emulate icon by selecting the Windows Start menu, and then type Emulate to find Studio 5000 Logix Emulate software application from the list. I have already set up the emulator with the Emulator 5570 controller in slot 2, RSLinx in slot 0 and 1, and a 1789 SIM32.IO module in slot 3. Now, let's select the Windows Start button again to start up RSLinx Classic communication software. I select the Windows Start menu button and then I type RSLinx to find the RSLinx Classic desktop application. I select the RSLinx Classic application from the list. RSLinx will start. The communication driver for the Studio 5000 Logix Emulator needs to be configured. I will select the Communications menu and then Configure Drivers. In the previous video, I created the virtual driver called RealPars VBP1, which has a running status. Now, if I select the DDE OPC menu and then Topic Configuration from the drop-down list, I see the topic I've created in the previous video, called RealPars XL. Okay, I'm done with RSLinx Classic, for now. I will download the Studio 5000 Logix Designer program to the virtual PLC. In the Studio 5000 Logix Designer software, from the Communications menu, I select Who Active. The Who Active window will appear, displaying all of the configured drivers, in this case, the RealPars VBP1 driver. I select the Studio 5000 Logix Emulate from the list, and then I press the Go Online button. In order to download the program to the emulator, in the Connected to Go Online window, I press Download. The download warning pop-up will display. I will select Download again to begin the download process. After the downloading, the progress bar completes to 100%. I will return to the Studio 5000 Logix Designer program. Notice that the controller is in Remote Program, which means the controller is not running. I will change the Remote Program state to Remote Run. I select the icon next to the Remote Program indicator, and from the list, I select the Run mode. A configuration window appears, asking to confirm putting the controller in Remote Run. I will select Yes. Now, let's look at the controller tags DINTArray and RealArray that I added before, and prepare to visually monitor the tags for the XL read and write operation. I am now ready to set up the DDE Poke VBA, Visual Basic for Application scripts for the read and write control buttons in Excel. I will now open the Microsoft Excel project, which I've already created. You can find the download link to this Excel file in the description. Starting with Sheet 1, I'll rename the sheet to Read-Write PLC. I name the D and E columns for Read and columns G and H for Write to identify where the data will be displayed. Columns D and E will be Read, Real, and Integer data, and columns G and H will be Write, Real, and Integer data. Remember, our PLC tag arrays have been assigned 10 elements each: DINTArray 0 to 9 and RealArray 0 to 9. In the Write Real CLX Values G column, I entered the floating point values I want to write to the PLC, and in the Write Integer CLX Values H column, I entered the integer values I want to write to the PLC. In the next few steps, I will use VBA development mode and use VBA scripting to perform the write operation. In order to place command button objects on the Excel sheet, I will enter into developer mode. To do this, I'll select the Developer tab, and then I select the Design Mode button. This will allow me to place control objects on the sheets. These control objects are essentially allowing me to create an HMI, or human-machine interface. Now, let's select the Insert button. This button provides an assortment of controls for my Excel sheet. Pressing the Insert button from the menu displays a Form Controls drop-down menu. From this drop-down menu selection, I pick the Form Controls button object. Once the Command button is selected, I draw a rectangle below the data under the columns G and H. An Assign Macro window will appear. Select the New button to create a new button. Now, the new button will appear. Let's give the button a new name. Right-click over the button and select Edit Text. I then enter Write CLX Arrays for the new name. When completed, the Write CLX Arrays button appears with the new name entered. Okay, here's where the fun begins. Right-click the Write CLX Arrays button. Handlebars will appear around the Command button. In the Excel Developer menu area, I select the View Code item. The Visual Basics for Applications window will appear. For the sake of simplicity in this video, I will write the VBA code that will perform much of the VBA RSLinx connection and write operation to the PLC and explain the VBA code in part. Under the Modules folder, I double-click the Module 1 and then start writing the RSLinx Open and Connect code. Next, I will write the DDE poke write command script in the Write CLX Arrays button event area. The script that I'm writing in the Write CLX button event is click and performs the connection to RSLinx and through RSLinx DDE communication to the PLC, and finally, the DDE poke function used to perform the actual write command when the button is left-clicked. This script will open a connection to RSLinx using DDE. This script will loop through for each of the Excel cells using the For Next instruction and display an error message box if there is an error. This instruction will take the real data in row 3+I in column G and write the floating point data to the PLC. With this loop, I variable equals 0 through 9 and the number 7 represents column G. This instruction will take the integer data in row 3+I in column H and write the integer data to the PLC. With this loop, I variable equals 0 through 9 and the number 8 represents column H. This instruction will terminate the RSLinx connection. Let's test the Write CLX Array button. With PLC Online, we can see the values are all set to 0 in the Studio Logix Designer Controller tag window. I return to the Excel Write Command button. I then left-click the Command button. This action will run the script behind the button and write the values to the PLC. Now, let's return to the Studio 5000 PLC program. The Excel values in column G and H are now available in the Dint and Real array tags, almost like magic. VBA can be very powerful and perform many things. I perform the same operation as I did for the Write CLX Arrays command button to create the Read CLX Arrays command button. After I right-click over the Read CLX Array command button, I select the View Code from the Developer tab. I start writing the code under the Read Command button event. Similar to the DDE poke command, I will use the DDE request method to read the data from the RSLinx DDE topic. I return to the Excel spreadsheet. I then left-click the Read CLX Array button. The script will perform and read the values from the PLC controller tags. This concludes the video, How to Configure Real-Time Microsoft Excel Write Communication from Rockwell Controllers. Stay connected and watch for more videos with real PARs for additional VBA lessons. I truly hope you have enjoyed learning what will support you in your upcoming Excel HMI-based project. If you would like to get additional training on a similar subject, please let us know in the comments section. If you enjoyed this video, please press the like button. Please check back with us soon for more automation control topics. Also, be sure to download the RealPARS app. When you download the app, you'll be able to watch an entire free course on PLC hardware. Just like this video, the lessons are all high quality and also very easy to follow. By downloading the RealPARS app, you have access to a wealth of practical knowledge as an automation engineer right in your pocket, and you'll also receive new fresh out of the oven videos each and every week.